So a lot of people ask me, am I stuck using y equals mx plus b all the time? Well, surprisingly enough, no. You can actually use the xy-intercept method. You just have to remember that one little thing. X-intercept, right, means y equals to 0. Y-intercept means x equals to 0. And when you do that in graphing, it becomes really, really super simple to do. And some people actually prefer this method over y equals mx plus b. Whatever. Let's try this. There's number 1 here. And number 1 is 2x plus y equals to 2. And watch how easy this is. I want to show you. Let's do the x-intercept first. X-intercept. You know y equals to 0 when the x-intercept happens. So check this out. This y now is 0. If that is 0, right, that leaves you with 2x equaling to 2. Divide each side by 2. You got x equals to 1. And check this out. You now have a coordinate, 1, 0, because it is the x-intercept. So at 1, 0, we're about right here. Okay? Now, let's do the next one. The next one would be, of course, the y-intercept. And this is even easier because y-intercept is when x equals to 0. So I'm going to clean up this equation up here because I want to show you this again really close without any kind of marks on it at all. So I'm just going to write out that same equation again, which is 2x plus y equals to 2. But watch what happens when x equals to 0. That means this term is 0, meaning this whole thing is now gone. And look at your answer. It's right there, y equals to 2. Isn't that cool? So y equals to 2 is right about here. Now, if we're really, really smart, we can actually graph this quite nicely, and I'm going to try to graph it as accurately as possible right up like that. Ugh, that was terrible. But, you know what? We're going to do our best there. My suggestion again to you is make sure you use a straight edge. Oh, that is terrible. I'm going to try that again. My goodness, that's horrible. Okay, so here we go. There's the x-intercept at 1. There's the y-intercept at 2. I know that this is, I'm going to try. Oh my goodness, this is terrible. Here we go. At least that one's a little bit better. There we go. I can live with that one. Okay, let's go on to the next one. Here we go. That's hilarious. Look at equation number 2, which is this one. Look how beautifully this is set up for x-y-intercept method. Again, x-intercept means y equals to 0. Check this out. If y equals to 0, that term is gone. And look, we got x equals to 7. How easy is that? Oh my goodness, that's just the easiest number out there. So there's 7 out here, right there. There's our x-intercept at 7. Do the same thing now, right, for the y-intercept. Let me rewrite this equation again so that you can see the whole thing. Remember, that was x minus y equals to 7. And if we're going to do the y-intercept now, the y-intercept, we know that x equals to 0. That means this guy is gone, leaving you with minus y equals to 7 or y equals to minus 7, taking that negative over to the other side. Putting that negative 7 right there on the y-intercept, look how beautiful this is. Right bang through there. Look at that. That's awesome. And lo and behold, there's our intersection, and that's the point that we're looking for. And according to this graph, if you look, that's about 3, look at that, 3, negative 4. And I'm going to tell you something. I did this algebraically, and that's exactly our answer at 3, negative 4. So even though I didn't use a straight edge on this, I got a pretty decent answer. But that's the point. The point is, this is your answer, but graphing is not necessarily the most accurate way of doing things, okay? So I want to see if we can now take it to the next step, which is going to be using our graphing calculators, using technology to actually solve this. You're in for a real treat coming.